If you are one of the 40 million drivers in the US that park their cars on city streets, getting an electric vehicle is out of the question. Today, we are going to talk about new ways to scale up our EV charging infrastructure in US cities.
This episode of Insider's Guide to Energy EV miniseries is powered by Power. Power helps your business transition to electric vehicles by simplifying charging, managing payments, and optimizing your charge. Welcome to another edition of the Insider's Guide to Energy EV series. I'm your host, Chris Sass. With me is my co-host, Niall Riddell. Neil, another episode on charging, and I think we have a different take today.
And you know what I think of charging? Absolutely love it. So hopefully we're going to dig into some of the gory details of how we can improve a driver's experience with different kinds of electric vehicle charging.
Well, I think it's important because one of the concerns we have from the grid is, how do we get enough capacity? And is everybody going to need, what level of charging do people need? And how do you get charging when you live in the city and multifamily? How's that all going to take place? And I think this episode's going to do a lot to explain one approach to maybe solve that problem. So what I'm going to do is bring on Nathan King. Nathan, welcome to Insider's Guide.
Hey, Chris. Hey, Niall. Nice to meet you both.
Well, it's a pleasure to have you here today. I know we've had some conversations in the past, but as I always like to start out with, why don't you tell our audience a little bit about yourself and what it is you do?
So I am co-founder and CEO here at Itselectric, a company that I started with my co-founder about 2.5 years ago. And we are EV charging that's purpose-built for cities. So what we've done is developed a business model and a hardware configuration that we believe is going to make it possible to scale up the number of EV chargers that we need in our urban areas over the next 10 years.
All right, so you're charging infrastructure for cities. What are some of the unique challenges of charging in the city?
Well, it's like anything in working in cities, it's space, right? We don't have space to locate charging stations to meet the demand that we have. And so curbside charging as a sector of the larger charging industry is really important for urban areas because we're not adding additional space to fuel vehicles. We're allowing drivers to park their cars where they normally do in cities and charge overnight the way that people that live in the suburbs do. For a little bit of context here, about 85% of EV charging in the United States happens in people's driveways and garages. And so your typical use case that we see is somebody buys an electric car and they'll have an electrician install a relatively good level 2 charger, or if they don't have a long commute, they just use the 120 volt charger that comes with the vehicle. And they charge overnight like you do with your cell phone. But if you live in a city and if you live in a townhouse or an apartment building, or maybe you're a renter that has a driveway, being able to install your own charger and use the charger off of your own grid is a challenge. And so what we're trying to emphasize here is that we need to make EV charging experience for drivers as easy and convenient and affordable as our counterparts in the suburbs.
So I'm 100% behind your thesis. For many years now, I've lived without a home charger and charged in a whole range of different scenarios. And I'm here in London, but across the UK and across Europe, we have challenges with where people can park their car, let alone where they can charge their car. So what we've started to see is a proliferation of different approaches. And that has, as you've already highlighted, different hardware and different business model implications. Could you take us into the hardware to start with? What is it that you've built and how does it work?
Sure, and the hardware and our business model are very complementary, but just really quickly, the first thing that we did was when we started the company a few years ago is we said, well, we've got about 40 million cars in the United States that park on city streets. What would be the best way to charge those vehicles? And when we looked at curbside, we thought, well, this makes sense because people are storing their cars on the street long term, and they can do this overnight charging. And so then the conclusion was, well, we need to find hardware that can really be situated on that curbside. And when we looked out in the North American market, we didn't see anything that really suited that use case. Chargers in this country are, really designed for being installed in driveways, garages, commercial parking lots. We didn't really see a piece of what we call street furniture. We need something that's very durable, very simple, able to withstand abuse. My background is in architecture, and I'm currently a licensed architect, so I'm happy to kind of talk about how we think about things from a design perspective. And when we looked over on the other side of the pond, we saw, wow, there's actually quite a number of different solutions for charging at the curbside. So here in North America, we have zero, but over in Europe and UK, there are quite a lot of different configurations that are really kind of designed and purpose-built for that curbside configuration. And so our hardware is very similar to what we see deployed in, I believe London has about 20,000 or so curbside chargers. They look like bollards, we call them bollards or charging posts. They're made out of metal components. They're very durable. Our charger is built the same way, and it features crucially a detachable charging cable. That's one of the big differentiators that we have here at Itselectric, that the cable that connects to the charger to the car is not permanently attached. And actually, the driver keeps the cable with them. So when you unplug your car and you drive away, all you're left with on the street, that piece of street furniture, is just a very slim metal post that kind of blends in with the rest of the urban context. And we're not taking up space with cable management systems or looping capes over hooks or anything like that.
So on that basis, do you have to have a unique cable that works for you with this solution, or is it a generic, the standard vehicle cable that gets delivered when your car arrives?
So here's what I'll tell you. We are using the same, we call it on the charger post or on the charging bollard. There's a port. It's the same charge port we are using that is being used in the EU and the UK. We think that there will be some of the companies on your side of the pond coming over to the US and deploying. Our cables will be fully interoperable with those charge ports. This is a nice moment to maybe get a little bit more in the weeds too. One of the big advantages that we have as a company is we don't have to decide what connector to put on the end of our chargers. You folks have the luxury of having this all standardized. In this country, it's not standardized. So there's the J1772 standard, which is currently everybody but Tesla. And then there's the Tesla connector or the NACS connector or the J3400 connector. Starting next year, though, everybody, the industry, even though regulatory agencies have been pushing for the J1772, nonetheless, the industry has decided they're going with the Tesla connector. But still, in this country, we're going to have millions of cars with the older version, with the beta, the VHS versus beta. We're still going to have a lot of people with beta VCRs. But the advantage that we have is we can give drivers the detachable cable that has the correct charging port, or the correct charging connector for their charge port on their vehicle.
So a silly question. A lot of people drive EVs because of the environment, and they're making an impact. If everybody has to carry their own cable around, aren't we producing a whole lot more cable and using more copper and resources to sustain this EV ecosystem? Neil's shaking his head no, for you listening. Just like I said, it's a silly question, but that's what I was hearing when you were talking about this.
What I'll tell you is when we diligenced our decision to go with the detachable cable, we thought about a lot of things. One thing that we saw being a problem in this country is cable theft and damaged cables. Cables will sort of wear out on their own, especially in the curbside condition where there's things like road salt. Curbside chargers will never have a canopy over them like you will have in a gas station where the pumps are protected. So wear and tear is a big issue, especially when they're just sort of left out and exposed. And then, of course, cable theft. Like you may have read some articles. It's a big problem in places like Colorado and in California. We've talked to property managers that are replacing their cables multiple times a year. So for us, we avoid those problems. We don't avoid them completely, but we can definitely mitigate them because, first of all, the cable is left out of the elements, or it's kept out of the elements most of the time. And so that wear and tear just from the exposure to the elements and use is reduced. And then also it's not exposed to theft and vandalism. And if those things happen, and they inevitably will, it's quite easy for us to replace that cable. We just have a driver replace their cable, and there's no need to call an electrician and roll a truck. So I don't really think that over the lifetime of the charger, it's that much of a difference in copper. It might be more, but the operational advantages that we're sort of unlocking sort of cancel that out.
Yeah, and I didn't want to get hung up on it. Like I said, it just was something that kind of at face value came up. I do have a question on, we talked about the UK, and Niall's can attest to stuff there, and the US. What are some of the differences on the city architecture of putting power to the curb? I mean, are the cities wired for this? I'm not aware of utilities having a lot of extra capacity throughout the city. How are you handling actually installing this somewhere?
Yeah, and I love talking about it this way, because usually I kind of talk about our business model approach and how we connect our hardware, and then we kind of talk about the differences between the UK and the US. One big difference that we have here, and this is getting into the weeds, but the most of the electrical distribution in the EU and the UK is a 220 volt feed. And so what we call the accessory utility feed. So these are the conduits that feed lampposts and traffic signals and parking meters and other kinds of electrified street furniture. That's all 220. In many cases, also three-phase. So it's relatively simple for folks in Europe to install what we call here in the United States a level 2 charger. So a 220 volt charger. Something that'll get you a full battery on a fairly big battery pack overnight. Here in the US, and there's a couple exceptions that prove the rule, but generally speaking, all of our accessory utility feeds are 120 volt. So what we can't do is easily go to, like, say, an existing lamppost or connect through a subgrade connection to the existing accessory utility feed and get that 220 or that 240 volt connection. Is just not there. Everything's 120 volt in this country. And so upgrading those service lines requires extensive coordination with utilities. What our business model does is kind of avoid that utility interconnection problem, generally speaking. Where we do have curbside chargers in this country, they're all more or less, kind of generalizing here, but they're generally pilot programs that are sponsored by utilities. So utilities are interconnecting directly to their mains in the roadway, and that's how they power the curbside charger. That's a very complicated and expensive process, and in some cases, because of our grid constraints, we're not able to put any additional load on those utility conduits. So what we do instead, not to bury the lead here, is what we call a behind the meter connection or a behind the property line. We let buildings power our chargers, and which is great in cities because that same problem around density and lack of space actually becomes our ally. Most buildings have enough spare capacity to power a level 2 charger, particularly the commercial buildings that we're looking to work with. And once we find that spare capacity, it's slightly more complicated, but not much more complicated than a driver in the suburbs having an electrician connect a level 2 charger to their electrical supply. So we've removed that sort of interconnection coordination process that is currently the way that we're trying to do curbside charging in this country by just connecting to existing capacity that's already at the correct voltage that we need through the buildings that we have in our cities.
Nathan, that's a fabulous rundown. I'm super conscious that you've clearly studied some of the UK market, because sat here, the idea of taking your cable with you everywhere is completely normal. The range of different street side furniture is varied. We've seen bollards, we've seen lampposts, we've seen through curb, we've seen under curb. But this connection to the building becomes really interesting because, like you say, it overcomes this big question of a grid connection. However, it does now mean you've got civil work into a building, you've got a relationship with a building manager, and you've got civil work out onto the street. Can you tell us a bit more about the challenges that you have to overcome with the various bodies involved in putting infrastructure in place when you've got, you know, local regulatory metropolitan authorities for the city's level, and then obviously a building or a building owner on the building level?
Yeah, and there's a bunch of different ways that I can answer this question, but the first maybe larger point that I'll say is installing a curbside charger, no matter how you do it, is complicated. And so we're not saying that what our approach is solves all the problems. All we are saying is that we think we've found the easiest way to do it, the path of least resistance to get that charger installed. If you are connecting directly to the utility, you mentioned civil work and road work versus sidewalk work. Those are two different categories. Roadway work is exponentially more expensive. Once you go past the curb out into the street, you're talking about repaving certain portions of the street. You're talking about partial street closures. It's a different set of permits. There's way more utilities out in the roadway than you have under the sidewalk. What we do instead is we're keeping everything between the building and the curb. And that's a different set of civil problems. It's not completely straightforward. There is some complexity there, but it's less complex than going out into the road. And from a technical standpoint, again, it really isn't that much different than, let's say, I have a garage, I have a driveway, I live in the suburbs, I have an electrician do some below grade work to run a power line to connect to the charger. It really isn't that much different.
No, I was just thinking the challenge you have when you install a home charger is often around things like the length of the cable run, ensuring you've got right earthing in place. Do you have some of these regulatory issues to consider around earthing and safety when you're bringing power out of a private building into a public space?
Oh, of course. And, again, I'm going to reference back my experience as an architect. We have the National Electric Code here. We have building codes. The utilities themselves sometimes have requirements for how we install things. We understand all of that, and the installations that we're bringing from building to curb are in keeping with those codes and regulations. It isn't that much different than, again, going out into the street and digging up the street and running a connection between the utility and the roadway. But again, it's trading off one set of complexities for a different one. And I don't want to say that what we're doing is eliminates all complexity. It's just less complex.
It's quite a fascinating space because we've started to see the emergence in the UK of various solutions called Curb E and Gully, where they take power out of the building and bring it into a private location for an individual to charge. Now, you also mentioned that you have a different business model. How does your business model work around this solution?
So there's a lot of things that I do want to try to talk about around our business model, which, again, as I said before, is sort of supported by our hardware configuration. So we designed our charger to be easily connectable behind the meter. Working with building owners instead of the utilities has certain advantages. I'm just going to mention a couple of them. One advantage is that we're skipping the utility process, but I want to also just talk about our community approach. When you go to a city and you ask them to set aside a parking space for EV charging, they're going to be very concerned about the community reaction. So what we have instead, when we go to the city and ask permission, is we have, by definition, permission from that property owner who has the frontage along that parking space. And so it's just a different sort of ask to the city. We're not saying we're taking away that parking spot from that property owner. We're saying, actually, that parking spot is not only okay with us taking that parking spot for EV charging, they want us to do it. That's a feature, not a bug. We think that community buy-in, community involvement with this transition of vehicle fueling is necessary. The other thing that I'll say about our hardware configuration is that one of the advantages of our particular configuration is that we can locate some of our equipment inside the building and keep it safe from the elements. So the hardware that's on the curbside is mostly just sort of a hollow box with the connector on it. But inside the building is where we keep our more sensitive equipment, and that protects it from swings in temperature and things like road salt and temperature differentials. So this again is a hardware configuration supported by the business model. I know you guys have other questions, but the other thing I want to point out about our business model, and I can pause, but just is this question around utilization and whether or not we're selling charging hardware or whether or not we are a charging network.
Well, I think that's a valid point to answer, right? I mean, I think from our previous conversations, I'm assuming you're a charging network.
Yes.
And that's where you're going. What I'd like to do is transition to a different question, because as we've talked and I've had more time to digest and I listened to you speak about the business model, I'm wondering what the utilities think, because isn't there a separate rate for commercial use energy as opposed to a home, what I get as my home? So if you're now putting this into and you're the building owner, are you falling under commercial rate with the utility? Is the utility happy about this, or are you falling under the same regulations of a regular ratepayer?
So it's a good question. And in this country, it depends. We are looking at two different ways of doing this right now. In one case, what we can do is tap into the building's power supply behind the meter, right? So the power is being fed into the building. It goes to a panel. We're tapping into that panel. And then we just negotiate with the property owner how much they're paying for power, and we reimburse them for the power that we use. This is actually how it's being done in commercial context, right? So if you go to a Whole Foods and there's a charging network installed there, EV drivers are paying the charging network for the use of the charger. The charging network figures out how much power they're using. They reimburse the host property. Like this is being done, and we're not proposing to do anything differently. We're also looking at if it's possible to have a established meter in the co-located in the property in the building itself that has that different
But
rate.
then you're going back to the utility, right? So the problem statement that you said earlier was it's easier to deal with the building owner in some way, right? So if you go for a meter, you need the utilities buy-in?
Well, getting a meter is very different than doing an interconnection. So what we're doing is if the service has that spare capacity, so most of the time the service that's brought to a building is oversized because the utility expects future expansion. So we're tapping into the spare capacity in that service that's brought to the building and putting a meter on that. That's very different than saying, I need to interconnect a brand new thing into your utility main in the roadway. We can do it either way. In cases where we think it goes faster to do the behind the meter connection, then that's our preference. And in cases where the utility is able to get that dedicated submeter for us, then we do it that way. In either event, the property owner does not pay for the power that we're using. We're always going to reimburse the cost of the power, and we figure out what that is before we install the charger. Just making it very clear, for the property owner, there's no cost. We are installing the charger ourselves. We own and operate it. We reimburse the property owner for any costs associated with using their power. We've already paid the contractors to do the installation. What we like to say, the only thing we need from the property owners is permission and access to their building wants to make that interconnect.
So I love a bit of tax. Do you guys have different tax rates for domestic properties versus, business rates? So we in the UK face a challenge. We get 20% tax on business electricity, but only 5% on domestic. So this would cause all sorts of weird tax headaches, I'm sure, when you start cross-selling out of a building into a public domain.
It won't be that complicated for us. EV charging is just a standard sales tax. Cool. So our drivers are going to pay a standard sales tax. And what, like I said before, what we do when we work with the property owners is we either get our own commercial meter and they don't have to worry about it, or we negotiate in advance what we're going to reimburse them per kilowatt hour.
So you can then enable a standard rate for anyone who arrives at a charge point in public. They can find an Itselectric charge point and they pay the same rate everywhere they go.
That's right, because we're doing like an average. We're going to make a prediction on what the average cost to the utility is going to be for our different installation configurations. And we'll say, okay, well, that's where we'll set the floor. We'll put an adder on it. That's how we earn income. And that's what drivers will pay.
Which then leads to a scenario whereby you've basically combined 2 or 3 different business models together with a piece of smart hardware to deliver a network that is fundamentally different to, I think, anything that I've discussed or seen before.
Yeah, I mean, the business model is working in partnership with the property owners to make the electrical connection. And then within that, there's different technical ways that we can power the charger, but we're always going to be working with that property owner. I don't think yet I haven't mentioned too that there's a revenue share aspect with it as well. So the building owners that we're working with earn a small portion of the charging fees as passive income. So that sort of incentivizes them to work with us, and it's a way that they can sort of lease out that spare capacity that they have in their electric.
So what I'm hearing is you have to work with the cities as well, right? Because if I live on a street
Yes.
and parking's limited in most of our inner cities, it's hard to park. There must be some scheduling or software or some way to dictate who gets the space where my charger cable can reach. So, in front of my building, maybe there's 4 or 5 spaces, and maybe I have the ability to charge a car or two or several. Does policy at the city level need to change then? Or is there some other regulation that changes to make this available so that someone just doesn't park there for a week? If I got my parking space and it's not a snow emergency, my car is staying. I don't want to have to go hike and get my car, and I take public transit during the week, or I walk to work.
So absolutely, we need to work with cities on parking enforcement. The good news for us as a company is, like, even before we started this, many cities had these regulations in place. So, for example, here in New York City, the way that it works is if you park next to an EV charger, you have to be plugged into it. So you can't be a gas car, and you can't just be an EV that's parking there. You've got to be actively using the charger. And when you see the signage will say something like reserved for EV charging only. And then there are different ways to price the charging service to incentivize the driver to clear out the spot once their battery is full. There's other things too, and I can get into the weeds here. There's other things too where we set a lower rate overnight than during the day, so drivers feel comfortable plugging in and going to bed and not having to worry about waking up at 4 a.m. and moving their car. And during the day, a higher rate to incentivize the driver to move the car and open it up for a different driver. The traffic enforcement in these cities enforces that. So you get a ticket if you're not charging or if you're a gas car. Definitely icing out is a problem in our cities, but it's one that we see kind of slowly being solved.
This is a really, really interesting to hear, because you have some quite progressive policies that support the transition into electric. Here in the UK, we don't tend to do dedicated bays for AC or low power on-street charging. We do see some overstay fees to encourage people to move off the charger after they've filled up the vehicle. So the charging speed drops and they're encouraged to move on. But what you're describing is something that is really quite progressive, because you've got a commercial incentive for people to offer up their power on the street. You've got a restrictive environment for who can use the bay. You've got the ability to nudge a driver out of the bay with a financial penalty, meaning that finding an on-street charge, you're overcoming a lot of the challenges that I think on-street charging solutions are seen here in the UK. I'm very impressed. It sounds quite unique. Do you have any competitors?
The people that we're most interested in are the UK companies. I think you had a company called Chargy on more recently. They do lamppost retrofits. There's a company called Ubertricity that was bought by Shell. I don't think they're called Ubertricity anymore. I think they're called Shell.
I think they're still Ubertricity by Shell Recharge. I think they are.
Oh, they're still Ubertricity by Shell. Okay. There's a company called Connected Curb.
Yeah.
By the way, I'm an admirer of all of these companies. Connected Curb, I think, is one of the larger networks. There's a few others as well. I think that those companies are very interested in breaking into the market. Very rough math, but just in the Northeast U.S., we think there's about 6 to 8 million drivers that park on city streets. I don't know. I can't remember exactly how many cars there are in the UK. But I think it's about a third of the number of cars that we have. So like the total market in the UK is probably one of our, sort of geographic regions. So if the UK is large enough to support, about a dozen different curbside charging networks, the fact that we only have, a couple here in the US, I think there's a lot of room to grow.
There's a huge space to grow. I mean, here in the UK, we're seeing some of these networks you talked about. Ubertricity is probably heading on towards 10,000 connectors. Connected Curb, Chargy are both 3,000-4,000 each. where are you in terms of deployment in the US, and where do you see that growth coming from, city by city?
Well, we're still breaking into the double digits here. So right now, as I said, we're about 2.5 years old as a company.
Yeah.
What we managed to do is to design and build our charging hardware. That was the first challenge that we had.
Yeah.
And get into place all of the different certifications that are required in the U.S. We've run small pilots and deployments. At the moment, we have 7 chargers installed in Detroit and in Brooklyn. But these are chargers that are revenue generating. These are commercialized chargers. We've completed a manufacturing run. And at the moment, what we're doing is sending chargers to where they're going. And I can sort of talk about our pipeline and what we're doing next. We also just closed our seed fundraising round. So we raised about $6.5 million. So that's really something that is going to help us sort of hire up and get some of the bandwidth to actually run some of these, hiring project managers and getting the chargers installed. I can tell you kind of like the competitions and the grants that we've won, but I'll just sort of pause and see if you wanted to.
Yeah, I think that's fantastic. It helps give an idea. Early stage company, got some real world deployments going with some revenue going, which is usually helps the investors, helps close that seed round. And then it sounds like once you get some more, you'll go to a round to scale this thing up. It sounds pretty interesting. I want to thank you so much. This has been an amazing conversation from my point of view. For those of you listening, not watching the video, you could just see Niall's ears perking up every time we went there, because this is such a unique model compared to what we've had on the program so far that we're interested to watch this and see how this goes, and hope to follow up with you in the near future to when you have a little bit larger deployments and have some more real world data to feedback. We'd love to have you back to talk about it. Nathan, thank you so much.
I'd love to come back. Thank you guys. Thank you so much.
For our audience, this has been a great episode of Insider's Guide to Energy EV. If you want to do us a favor, if you like the content, make sure you like and comment. Do that on our YouTube channel. Do it wherever you get your podcasts. And don't forget to subscribe. We'll see you again next time on the Insider's Guide to Energy EV series. Bye for now.